Hello and welcome to our lesson on dividing decimals and a review of the order of operations. So when we are dividing decimals, the process is pretty similar to dividing whole numbers, which has kind of been the theme throughout this unit. The only difference is that we're going to put a decimal point in our answer. And if the number that we're dividing by, if our divisor, again that's the number we're dividing by, if that number is already a whole number, then we place the decimal point directly above the dividend. Oops, I meant to put above. Sorry. Directly above the decimal point in the dividend, okay? Now, if your divisor is already a whole number, the decimal is just going to go right where it would instinctively go, and I'll show you with an example in just a few minutes. If, however, your divisor, if the number you are dividing by is a decimal, then we're going to want to move that decimal. We're going to move the decimal to the right until our decimal number becomes a whole number. And this is a legal move as long as we move the decimal in our dividend the same number of times. And when we get to an example again, I will show you why. And then the good thing about division, well, there's a couple of good things. We have technology that can not only do the division for us to verify our work, but if we wanted to verify without that, we could also use multiplication. So division can be checked with multiplication and with calculators, okay? So let's look at the process. For instance, on example 1, if we wanted to take 270.2 and divide it by 7, 7 is our divisor, that's going to go outside of the box, and 270.2 is our dividend that goes inside of the box, and our decimal is going to go right above the decimal in the dividend. Okay, so it's just normal division from here. We are trying to see how many times 7 goes into, well, it doesn't go into 2. So how many times does it go into 27? Well, 7 goes into 27 3 times. We're going to put that above the 7. 3 times 7 makes 21. And the 3 goes above the 7 because that's the place we're dividing into. So 3 times 7 is 21. If we subtract, we have 6 left over. We're going to bring down the 0. And how many times does 7 go into 60 now? How many times does 7 go into 60? Is going to be 8 times. So 8's going to go here again because we're dividing into that place value. So 8 times the 7 is going to give us 56. We're going to subtract to get 4, and we're going to bring down the 2. So lastly, it's how many times does 7 go into 42? And 7 goes into 42 6 times. And that's going to be our answer, again, with our decimal point in this directly above the decimal point in the dividend. So 7 times 38.6 should take us back to 270.2. So if we wanted to do a check, again, let's multiply here and make sure this works. So that's 42, that's 56 plus 4, which is 60, and then 21 plus 6, which is 27, and our decimal point goes right there, so we're good to go. All right, so this quotient, this answer, is 38.6. All right, let's try that again. So in the next one, we have 32 8.32 divided by 32. So 32 is our divisor, and 8.32 is our dividend. And our decimal, again, is going to go right here. Okay? So we're trying to divide 32 into, well, it's not going to go into 8, but it will go into 83. And so the quotient part is going to go right there. Okay? How many times is 32 going to go into 83? We're going to say twice, because I know 3 times 30 would be 90, which is too big. So 2 times 32 is going to be 64. We're going to subtract. And we have to borrow, so that's going to be 19 left over. And then if we bring down the 2, how many times is 32 going to go into 192? Well, let's see if 6 times will work. Oh my gosh, sorry. Let's see if 6 times is enough. So 6 times 32. 6 times 2 is going to be 12. And then 6 times 3 is 18 plus the 1 makes 19. Oh, it's perfect. We subtract. We have 0 left over, so it's going to be 0.26 for our quotient. So this answer is 0.26 or 0.26 if you really want that 0 there. Okay? And hopefully this is making sense. Hopefully this is a process we've seen before. We're just reviewing, right? Dusting off the cobwebs. Okay, so 0.5 is going to be divided by 4 this time. So 4 is our divisor. And we're going to be going into 0.5. So our decimal point's going to be here. And something a little different is going to be happening here. So if we look at how many times 4, oh, I thought I hit, how many times does 4, it doesn't go into 0, does it go into 5? So 4 goes into 5 once, so we're going to put a 1 here, right? It doesn't go into 0. And 1 times 4 is going to make 4. If we subtract, we have 1 left over. Well, when we're dealing with decimals here, we don't want to introduce a fractional remainder of 1/4 and put fractions and decimals together. It's one form or the other, not a combination. So if we have a remainder there, what we can do to continue this process is put zeros at the end of our number, as many zeros as we need. So I'm just going to stick 2 there for now, because adding zeros to the end of my decimal number doesn't change its value. So now I'm going to bring down a 0 and try to continue this. So 4 now into 10. 4 goes into 10 twice, and 2 times 4 makes 8. If we subtract, we get 2. So I still have a remainder there. Let me bring down another 0 and see if I can finish this off. So now 4 into 20 is going to be exactly 5. 5 times 4 is 20 with nothing left over. And so now that the remainder piece is 0, we can stop. So this decimal, this quotient answer is going to be exactly 0.125. So this is equal to 0.125 or just 0.125. If you want that 0 in front, cool. If not, also cool, right? We can see here both ways are going to be acceptable. Okay? So those are what we call, those are all called terminating decimal answers. We're going to see some variety happen here. Now, those are all whole number divisors. We're going to look at next are divisors that are decimals. So for instance, in number 4, we need to try to figure out, what color am I on? We need to try and figure out how many times 1.5 is going to go into 64.85. Now the rule here is we want to divide by a whole number. So if I wanted to make 1.5 a whole number, what I said was just move the decimal 1 time so that it becomes a 15. And if I do that here, I have to do the same thing in my dividend. So instead of dividing 1.5 into 64.85, I would be dividing 15 into 648.5. Now, why are we allowed to do that? So let me take you on a little tangent for a second. Don't write this, just so you understand. We're saying 64.85 is being divided by 1.5. So another way to think about division is as a fraction, right? And with a fraction, we saw that we can make equivalent fractions by multiplying our numerator and denominator or by dividing our numerator and denominator. So for instance, if I multiplied my numerator by 10 and multiplied my denominator by 10, I could make an equivalent fraction. That's something that we do to get common denominators, right? Now what happens if I multiply 64.85 by 10? Well, 64.85 multiplied by 10, we're going to end up with a 0 here, and then 5, and then 8, and then 4, and then 6, and 2 numbers past the decimal. What happens is my decimal moves 1 time. Okay, so my decimal moves 1 time and becomes 648.5. And the same thing's going to happen at the bottom when I multiply by 10. It becomes 15. So the reason I'm allowed to move my decimal the same number of places in my numerator and denominator is because it's just like multiplying the top and bottom of a fraction by 10. Okay, so we're moving our decimal, and that's legal because we're not changing the value of those decimals. So or of the proportion of the decimals, the fraction if we were looking at those together. Okay, so we move the decimal the same number of times, that way we're dividing by a whole number and not a decimal. So this becomes our problem here. All right, so now the decimal is going to go right here in the answer, same spot, and 15 we're going to divide into 64 4 times. 4 times 15 is going to make 60. So when we subtract, we get 4. We're going to bring down the 8. And then 15 is going to go into 48 3 times. 3 times 15 makes 45. We're going to subtract. We're going to get a 3. Bring down the 5. And 15 is going to go into 35 twice. Twice is going to give us not enough space. Twice is going to give us 30. And then if we subtract, we get a 5 here. And I'm going to see if I can take this out a little further. So I'm going to add on a 0, because I still have a remainder that I don't want to deal with. So I'm going to bring down a 0. And 15 is going to go into 53 times. That makes 45. And we're going to get the same thing. Oh my gosh, I need to move all this up. I'm so sorry. I should have wrote smaller. So we're going to end up with a 5 again. And I could keep adding zeros here, but what's going to keep happening is we're going to keep getting a remainder of 5 because it's going to keep being 50. And so the 3, again, is going to happen here. The 45 would happen again. The remainder of 5 would happen again. Bring down another 0 would happen again. And so these 3's are just going to continue. So 43.2333 is going to continue. And we call that a repeating decimal. And so we're going to call this answer 43.23 repeating. And when a decimal repeats, we put that little bar over it to say that it's repeating. So that's what the ... the ellipses means. It's going to keep going. But when it keeps going with the same number every time, then we can put a bar over it to say that that 3 repeats an infinite number of times. So this is our quotient, 43.23 repeating. Okay, that was kind of an ugly one. And again, we can use technology to confirm. So let's go ahead and just make sure we didn't goof anything up here. So 64.85 divided by 1.5. And there you see it, 43.2, and those 3's just keep going on forever. Okay? Let's try another one like that. Let's take, so we want to divide 2.3 into 10.764. We want to make sure we're dividing by a whole number, so the decimal is going to move once here, which means it's got to move once here. So the division we're actually going to do is 23 into 107.64. So the decimal is going to go right there. And 23 is going to go into 107. 5 times, I think, is going to be too much. So let's go with 4 times. And 4 times 23, let's see, 4 times 3 is 12. If we carry the 1, we're going to get 9. Yep, that works. When I subtract 92, I'm going to have 15 left over. I'm going to bring down the 6. And then how many times is 23 going to go into 156? So let's see, 5, 6, 7. Let's see, what's 23 times 7? That's 14. That's too much. So it's going to be 6. It's going to go in 6 times. 6 times 3 is 18. We'll carry the 1 to get 13 there. We're going to subtract. And so we've got 18 left over. And now we're going to bring down the 4. How many times is it going to go into 184? Is going to be the 7. 7 times 3 is 21. That's 14, 15, 16. And oops, not going to be. Look, so see what happened. This is actually a good learning for you. When I multiplied 23 times 7, I end up with, oh, I can't. That was a 6. 23 times 7 is, 7 times 3 is 21. So if I carry the 2, that's 7 times 2 is 14 and 2 is 16. And what happens is my difference is 23, which means that could have gone in one more time. So not 7 here, but 8. And 8 times 23 is going to be exactly 184. So no remainder, which is good. That means our exact answer here is going to be 4.68. And again, we have technology, so let's use the technology to make sure we're doing this correctly. 10.764 divided by 2.3 is 4.68. Okay? And one more here. If you're feeling confident about this, I think this would be a great place for you to try this out. So feel free to pause the video and give it a shot. Otherwise, let's see. 0.32 is going to divide into 5.264. So we're going to have to move the decimal. Decimal is going to have to move 2 times here, which means we'll have to move it 2 times here. So what we're really going to be dividing is 32 into 526.4. So decimal is going to be right here in the answer. So 32 is going to go into 52 once. 1 times 32 is 32, so we'll have 20 left over. How many times is it going to go into 206? Let's see, 32 times 5 is 160. Nope. So let's do 6. 6 times 2 is 12. If I carry the 1, I get 19. Perfect. So now when I subtract, I've got 14 left over. And then I'm going to bring down the 4. And how many times is 32 going to go into 144? So let's see. 32 times 4 is going to be 8, 128. And yeah, I think that'll be good. So 4 times 32, again, is going to be 128. If I subtract, then I'm going to have 6 and... what am I doing? Guys, I can subtract, I promise. This was 144. My brain. I gotta borrow here to make... Jeez, I gotta make that a 3. Okay, so that's gonna be a 6, and then 16. I'm like, something's wrong. Yeah, what's wrong is I'm a goofball. So 16. So that was the end of my decimal, but I have a remainder that I do not want. So I'm gonna add a 0 here and see if I can't keep going. So I eventually can end this. I'm gonna bring that 0 down and see how many times 32 goes into 160. So it's going to be 5 times exactly. 5 times 32 is going to be 160. And so now I have my 0 remainder. So 16.45 is going to be our exact answer. Okay, so there's dividing decimals. Super fun. I actually have a couple more I want to show you. These are all either repeating or terminating decimals. That's something I was trying to spit out earlier, but they aren't always as nice. Sometimes we have some strange things happen, like on this one. Same process to start, and you're not going to notice anything different about it, but if we're trying to divide 0.48 into 17.5, our decimal is going to have to move twice here. So twice here means I have to add a 0 to move it. So what we're going to be dividing is 48 into 1,750. And now we have a decimal here, which we may or may not need. So let's go about our division here. 48 into 175. 4 is going to be too much, so let's go with 3. 3 times 8 is 24, so I carry the 2. That's 12, 13, 14. If I subtract, I'm going to have 31 left over, so I know I did good on the 3. And then I'm going to bring down my 0. How many times is 48 going to go into 310? This is going to be, what, 6 times? 6 times 8 is 48, so there's an 8, carry the 4. 6 times 4 is 24, plus 4 is 28, so 288 here. I gotta subtract that, so I'm going to have 2 there, and then 38 minus the 20 is going to be 2 there, so 22. Now I need that decimal because I don't want that remainder, so I'm going to put a 0 here, and I'm going to bring it down. And into 220, 5, it's going to be too much. If I multiply by 5, yeah, 5's too much. So we're going to go 4. And 4 going here. 4 times 8 is 32, so 2 carry the 3. 4 times 4 is 16, plus 3 is 19, so I get 192. When I go to subtract, I'm going to have 8 there, and then 2 there, so 28 left over. I can tack on another 0 if I want to. And how many times is it going to go into 280? 6 was too much, so let's go with 5. And 5 times 48. So 5 times 8 is going to be 40. So let me put the 0, carry the 4. That's going to be 24. And then I have 40 left over. And then I can tack on a 0. And we can see how this can just keep going. How many times is 48 going to go into 400? See, 9. Let's see, 48 times 9. It's way too much. 48 times, let's try 8. That's 64, so 48. And 6 is going to be 50. That's, oh my gosh, guys, I'm like way off here. Don't mind my brain. 48. There should be 2 in those in each 100, so I don't know. I was thinking 8. What am I? Don't mind me. Let's try 48 times 8 again. So 8 times 4 is 64. If I carry the 6, oh yeah, 8 times 4 is 32, and 32 plus 6 is 38, so that's going to be good. I don't know what I was thinking. So that's going to be 384, and we could keep going here. Obviously, this can continue, but I'm going to stop. And the reason I'm going to stop is not because this thing is necessarily going to go on forever, but because there were directions in this problem that allow me to stop. Okay, once I know that I want to round to the nearest 100. If I want to round to the nearest 100, that's this decimal here. I only need one decimal after it, because the decimal after it is going to tell me whether I keep that number or whether that number has to round up. And because after the 5 is an 8, that number will round up. So we're going to say that this thing is approximately, using this squiggly looking equal sign, that's the symbol for approximately, it's going to round to approximately 36.46. So this is not the exact answer because that decimal will keep going, and let's see how far it goes. In fact, if I take 17.5 and divide it by 0.48, 36.4583, and then we're going to get 3's that go on forever, but we don't need all those. So that's the exact there, but approximately 36.46 rounded. Okay? So sometimes we'll have decimals that will keep going, but if we're asked to round to a certain spot, just go one number past where you're trying to round. All right, now the next one, just again to give you a variety of skills here. It says to estimate the quotient and then actually figure out what it is. Sometimes it's good to get a ballpark of what you're looking for before you actually find it, right? So this number here, it's about 272, and this number here is pretty close to 28. So if I wanted to divide 272 by 28, I might get a good estimate, but even to be make this estimation a little easier, I could say 28 is pretty close to 30, and 272 is pretty close to 270. That would be a much easier division problem. That's going to be about 9, okay? So I know just by ballparking here, I'm looking for a quotient, an answer that's pretty close to 9, okay? So now that I'm in the ballpark, let's do the division. 28.4 having to divide into 272.356 means I'm going to have to move my decimal once here and once here. So I'm really taking 284 into 272 and then the 3 and then the 0.56. Okay, so decimal point's going to go here. All right, 284 does not go into 272, which is awesome. So 284, how many times is it going to go into 2,723? Goodness. Let's see. Let's try a 6. I'm just going to try. So 4 times 2, or plus 2, that's 48 plus 2 is going to be 50. 12 and 5 is going to make 17, so that's not looking like enough. Let's go 284 times 8. That's 32. 64 and 67. And then 16 and 6 is 22. And if I add another 284, man, 6, 5, carry the 1, 5, 2. Yep, I can get 8 times in there, 9 times in there. Good grief. Okay, so 9 times is going to be 2,556. You'd think I would have picked nicer problems for myself, right? Okay, so 9 goes in, 2,000, or 9 times 284 is 2,556. If we subtract, we're going to get 7 there, and 6 there, and 1 there. Perfect. And bring this down. How many times are we going to go into 1,675? So that's about 300 into maybe 5. Let's see, 284 times 5. That's 0, carry the 2. That's 2, carry the 4, and then 1420. Yeah, that's going to be good. So we're going to go 5 here. We're going to get 1420 here. And we're going to have left over 5, 5, and 2. Perfect. Now, how many times? Oh, well, I got a remainder. And I got a 6 to bring down. So let me bring the 6 down. 6 comes down. How many times we're going to go into that? Hallelujah, we already know because we saw that number right here. And so we're going to divide in 9 times to get exactly 2,556. No remainder, no need to add zeros. So this is going to be exactly, we would use the exact equals there, 9.59. And I said it was going to be pretty close to 9 with my estimate. So again, estimating is a useful skill, okay? And dividing by triple-digit numbers is super fun. Alright, luckily we've got calculators, so we can bypass some of these things, although, again, this is work we should be able to do. Now, just a couple review questions. Order of operations. Remember, if we put, now that we know how to add, subtract, multiply, and divide all separately, right? If we put these things together in one problem, we want to make sure we're taking care of our grouping symbols first. If we have anything in parentheses, brackets, or any other grouping symbols, we take care of those items first. And then we evaluate any expressions that have exponents. Then we take care of any multiplication or division. And these operations happen from left to right. And then we take care of, lastly, any addition or subtraction. And again, these will be happening from left to right. Okay? So for example, on number 9, division and multiplication means we're going to go left to right. So first, we got to take care of this piece right here. So 723.6 divided by 2. How many times is 723.6 divided by 2? So it's going to go into 7 3 times. It's going to go into 12 6 times. It's going to go into 3 once. And it's going to go into 16 8 times. Okay, so we're looking at, this becomes 723.6 divided by 2 is 361.8, and now we have to take that and divide it by, or no, multiply it. Oh, thank goodness, multiplying. Multiply that by 10. So when we take 368 and multiply by 10, we saw this earlier, it's just going to move the decimal, but if you don't believe me, let me show you again. Okay, multiplying by 10. We're going to get a 0, and we could go zeros all the way across if you want, right? All the way across, well, 4 times. 0 placeholder, and then we have 8 and 1 and 6 and 3. So 0, 8, 1, 6, 3, one number past the decimal. There it is, 3,618 instead of 361.8. So multiplying by 10 just moves our decimal 1 time. So this ends up being 3,618 for that final result. Okay, and again, calculator will do this for you. So if you said, if you said take 723.6 and divide it by 2, You get that. Now you want to take that result, 361.8, and multiply it by 10, and there it is, the answer that we just arrived at. Okay? Here, we've got some grouping symbols, so whatever's in there has got to happen first. So we're going to take care of what is 8.6 minus 1.2. Normal subtraction, we get 7.4 here. So now we're looking at 0.5 multiplied by, instead of 8.6 minus 1.2, it's going to be 7.4. So now we need to multiply 0.5 and 7.4. So what's 7.4 times 0.5? If we multiply, 5 times 4 is going to be 20. So we carry the 2. We get 35 plus 2 is 37. And we need 2 numbers after the decimal. So we have 3.70 for our final result. And again, we've got calculators. Let's verify. 0.5 times, in parentheses, 8.6 minus 1.2 is 3.70, same number, okay? And we got one last one, and I saved the best for last, of course, right? So here, no grouping symbols, but we do have exponents. So the first thing I would be working on in this problem is this, 1.2 squared. And that is a big highlighter. 1.2 squared means 1.2 has to be multiplied by itself. So if I multiply 1.2 and 1.2, think about what's 12 times 12, right? 12 times 12 is 144. 2 numbers past the decimal means this is going to be 1.44. So I have 20.06 plus the 1.2 squared becomes 1.44, and that's divided by 10, and all of that is over 0.02. So in the top of the fraction, division has to happen before addition. So I'm going to take care of the division part next. And 1.44 divided by 10. So we said move the decimal this way once if we're multiplying by 10. Guess what happens if we divide by 10? Well, the decimal is going to end up going the other direction. If you don't believe me, let me show you. So 10 into 1.44. Decimal is going to go here. 10 goes into 14 once. That's going to be 10. Got 4 left. And 44, it's going to go in 4 times. That's going to be 40. And if I subtract, I have 4 left. I'm going to tack on a 0 here. And how many times is it going to go into 40? Again, 4. So we get 0.144, the decimal moving the other direction. So now we have 20.06 plus that quotient became 1.44, and then we still have to divide by 0.02. So we'll do the addition on the top of the fraction next. Addition, 20.06. If we add 0.144 to that, remember decimals have to line up when we add. We're going to get 4 here because there's nothing to add to it. That's 10, so we carry the 1. That's 2. And then 20 here. Almost done. So I have 20.204 in the top of the fraction, and I'm dividing by 0.02 in the bottom. So now we can take care of our last quotient. So I'm going to put 0.02. It's going to go into 20.204. And I'm going to move my decimal twice here. Move my decimal twice here, which means decimal, my answer is going to go right there. So it's just 2. 2 is going to go in here once. And it's not going to go in there. It's going to go in there once. And I got a 0 here. It's not going to go into 0. And then it's going to go into 4 twice. And nothing left over. So that is going to be our final result. We're looking at 1010.2. And that was a fun one. Lots of math in that problem. All those operations. Now, luckily, again, this is something that the calculator could confirm for us. So if you wanted to do one piece at a time in Desmos instead of doing all that work by hand, although it's work you should be able to do, but nice to be able to have technology to confirm. Okay? So I think that's enough for this lesson. It should be enough to get you going on your practice. But as always, if you need some extra help, then just reach out. All right, guys, take care.